Okay. How are you today, Miss?
Oh, good afternoon. I'm fine, thank you. I just want to check my virtual background. Is it okay, correct or not?
Yeah. I think it's correct already. Thank you for joining us today, Miss. And
You're welcome.
I think we will start like 5 minutes again. Okay, thank you. think it's already 2 o'clock. Okay, let's start our event. Good afternoon, everyone. Welcome to the International Expert Sharing Meeting. And my name is Chacha, and I will be the Master of Ceremony for today's events. And today we will discuss and also learn about integration and optimization of renewable energy. Okay, but before we go to the next agenda, I would like to remind to all participants to don't forget to open your camera and also to use our virtual background that can be downloaded on the chat box to make our event more interactive and engaging. Okay, next. Okay, so for the flow of the activity, for the first agenda, we will have activity introductions. I'll explain about the background of the activity and also introduce all of our experts. And then for the second agenda, we will have opening remark from our representative from Simiotad. And then for the next agenda, we will have experts presentation sessions that will be separated into two sessions. For the first session, we will have two experts who will give their presentations, and then followed by the second sessions that also we will have two experts who will give their presentations, and then followed by the group photo and closing. Okay, for the background introductions, for the activity proposed, so the International Expert Sharing Meeting aims to strengthen academic and professional exchange between education experts across ASEAN countries and also China. By providing a shared platform for dialogue, the series encourages diverse cross-disciplinary interaction, supports regional knowledge exchange, and fosters deeper collaboration on emerging educational and industry trends. And for the future outlook, so the international expert sharing will be held every month with each session featuring a distinct theme. Topics will span various fields such as education, business, and engineering, providing a diverse and also enriching experience for scholars. Okay, so for today's event, we will have four amazing experts that are coming from the following institutes. For the first speaker coming from Chiang Mai University, Thailand, and then the next one coming from University Putra Malaysia, and then the next one coming from Curtin University, Malaysia, and for our last experts coming from Universitas Pajajaran, Indonesia. Okay, so let me introduce a bit about our expert background. So for the first expert, coming is Dr. Pruk Anggarangsi. He is an assistant professor in mechanical engineering at, and he is also an expert in renewable energy, gas technology, and he is a former director of Energy Research and Development Institute. And then he has also led large-scale waste-to-energy and biogas projects across Thailand. And he is also the author of multiple international publications and books on biogas and renewable energy. And then for our second experts, we'll have Dr. Nur Izri Abdul Wahab. He is an associate professor in electrical and electronic engineering at University Putra Malaysia, and he is also an expert in AI-driven power system operation and smart grid analytics. And he holds a PhD in electrical, electronic, and system engineering, and supervisor of PhD and master students. And then he's also an active researcher with strong impact, with more than 130 international publications and receiver of multiple grants. And for our third experts, we will have Dr. Jundika Chandra Kurnia. He is an associate professor at Curtin University, Malaysia, with over 15 years of research experience. And then he also an expert in thermal fluids engineering, energy systems, and computational modeling. And he already published more than 90 international journal articles with strong citation impact. And he's also an actively involved as reviewer, keynote speaker, and international conference committee member. And for our last expert, we will have Dr. Lucy Safriani. She is an associate professor at the Department of Physics, Faculty Mathematics and Natural Sciences from Universitas Pajajaran with expertise in material science. She holds a PhD in applied chemistry from Tohoku University, Japan, and offers 20 years of experience in academia and teaching in physics, and she also the author of 48 international publications. So as you can see that uh, all of our experts coming from different backgrounds. And okay, so for the next agenda, we will have opening remark from Simiao Ted. Okay, we will have opening remarks from Miss Cheng Chantala. She is the head of administration, finance, and planning division from Simiao Ted. Okay, so for Miss Cheng, the time and screen is yours.
So, very good afternoon, everyone. So, on behalf of CMOTD, I would like to warmly welcome esteemed participants, young innovators, learners, and presenters. It is a pleasure to be here with you today to explore a topic that is not only essential to the future of vocational education, but also exciting and inspiring on integration and optimization of renewable energy. As the global demand for energy continue to rise, so does the urgency to transition toward cleaner, more sustainable sources. Renewable energy is no longer just an alternative. It is becoming the backbone of our future energy systems. The transition toward a sustainable energy future is no longer just about increasing the capacity of wind and solar. It is increasingly a challenge of integration and optimization. As we move away from steady, predictable fossil fuel toward variable energy sources, the primary hurdle shift from generation to the sophisticated management of the grid. However, generating renewable energy is only part of the solution. The real challenge lies in how we effectively integrate these sources into existing infrastructure and optimize their performance to ensure reliability, efficiency, and affordability. From smart grid and energy storage to innovative technology and data-driven solutions, the opportunity ahead are both exciting and complex. Today's session brings together insights, ideas, and practical approach to address these challenges. Whether you are a student, professional, a presenter, this is an opportunity to deepen your understanding and explore our sustainable energy future. Last but not least, I wish you all the best and get fruitful sharing this.
Okay, thank you so much, Miss Cheng, for your great opening remark and for welcoming us. Okay, let's move to our next agenda, which is our main session, the expert presentation sessions. Okay, so for our first expert presentation session, we will have Dr. Pruk Anggarangsi from Chiang Mai University, Thailand, and also Dr. Nur Izri Abdul Wahab from University Putra, Malaysia. Okay, so for our first speaker, which is Dr. Pruk Anggarangsi, he will be discussing about clean energy from food waste, the forgotten resource, with case study in Chiang Mai University. Okay, so Dr. Brook, are you already here with us?
Yes. Hello, everyone.
Okay, good. Okay, guys, so Dr. Brook was one of our like in then like a couple times ago. Okay, so yeah, let's enjoy our today. Dr. Brook, the time and screen is yours.
Thank you. Okay. Okay, good afternoon. Thank you for having me, and thank you for the audience and our colleagues that joining us today. So today, I'd like to, I think, briefly, in 15 minutes to share with you what we've done in terms of Thailand development of biogas technology, of which I have been involved in the past 15 to 20 years. And the forward looking, especially amazingly, that it's coincide very well with the situation. I think everybody is suffering from the situation in the Middle East, especially Thailand, and relies heavily on imports, especially natural gas. So I think today's presentation would probably give you some idea of many resources and support us to be independent of these imports. And I like to show you the Chiang Mai University case where we demonstrate uh, such a practice. So committed to it used to be 2050 carbon neutral. Right now, people forget about the word carbon neutrality already. Everybody has to aim for net zero, meaning we assume that technology-wise, you can actually be net zero and you don't want to cancel out to be neutral again. So today I'd like to introduce to you the history of Thailand. Thailand has been the main producer of food to the world market, meaning Thailand has already been producing from 50 years ago logic waste in the process. So Thailand, fortunately, has been familiarized with so-called biogas technology since the 90s. Um, First biogas plant was implemented, and then lots and lots of development has been implemented in the Thai market. So currently, I can almost say biogas is basically common practice for almost all organic industry or food industries. All authority require biogas facility in order to issue permits to any new factory, any new livestock farms, any new poultry or milk farm. So it's basically common practice, meaning wastewater wise, Thailand has been doing okay with waste to energy. So what we like to focus today is the thing that we forgot, um, which is food waste. It has been mixed with general municipal waste for a long time. I think we have the same practice in Thailand, Malaysia, Indonesia, all Southeast Asia, and I'd like to persuade you all to see through this of why we should start separating this food waste, and it's not that difficult from what I'd like to show you. Um, So biogas has been basically known for centuries, and the good thing about biogas is we conserve the energy cycle on the orange circle here. Everybody knows that if you ferment something in anaerobic, you get methane, same methane as digging up from underground or under the oceans as natural gas. So in the methane cycle, everybody is almost always forget about the nutrient cycle, of which the nutrient in these organic the be digested and harvest methane out, you still have abundant source of nutrient that can replace a whole lot of chemical nutrient. And again, Thailand imported a lot of nitrogen nutrient or chemical fertilizers from the Middle East. So this comes up to the spotlight again in Thailand as renewable energy and nutrient conservation at the same time. Okay. And as I mentioned, Thailand has been developed a whole lot of biogas plant or power plants from livestock farms, from agricultural industries, and many resources. So we basically run out of wastewater to be treated for biogas. So that's why in Thailand, people start looking for solid organic waste, either food waste or market waste, supermarket waste, and anything that has been mixed and throw away with municipal waste. And this is a rough estimations of how much biogas we have ignored in Thailand. And maybe all of you have heard about that. If we ignore these food waste being mixed with a municipal waste, not only that we cannot have harvested biogas, but also these methane will be released elsewhere. And methane is basically a high potential greenhouse gas. So in terms of capturing biogas, you have multiple benefits from nutrient perspective, from energy perspective, and definitely greenhouse gas reduction perspective. So in Thailand, you have available resources. For example, in Chiang Mai, easily have 30,000 cubic meter of biogas a day if you can collect only half of the organic waste being thrown away. So general, I'm sorry, yes?
Sorry, sir. Yeah, I think we cannot see your PowerPoint clearly. Like,
Oh, something
yeah.
comes up.
Okay, okay,
Sorry.
now. Yeah, now we can see
Okay.
it clearly.
Okay, why is
Okay.
that? Okay, yeah. Sorry, something pops up. So general numbers, if you have 1 tons of food waste, you can easily produce this much energy, about 1.9 1,900 megajoules or 2,000 megajoules, or equivalent to 200 kilowatt hour of electricity, or 40 kilogram of LPG. So you can substitute a whole lot of energy out of these food waste. And apart from that food waste, if we are looking at food waste as separated food waste, Thailand also has another cycle, so-called used cooking oil cycle. It used to be collected and delivered to biodiesel plants and come back as vehicle fuels. So currently, all of these used cooking oil from restaurant or market are still be collected. But right now, currently, they are all collected and produced sustainable aviation fuels, because Thailand also import a whole lot of aviation fuels. So sustainable aviation fuel, one big topics available in Thailand, and also big industry has already been set up a facility for aviation fuels. Regarding biogas technology, I can say technology is very available, especially in Thailand and Southeast Asia. I've been working with quite a few companies from also Malaysia and Indonesia to assist them installing biogas power plant for palm oil mill effluents and other waste. So technology-wise, it's very straightforward, and a lot of technology can be chosen from. Today, if we are to focus on solid waste, I would love to introduce to you another technology called dry fermentation, where you are operating with a very higher solid contents compared with wet fermentation that you commonly found in palm oil mills or food waste, water, or livestock farms. So this facility is what we try to introduce to the society, municipalities in Thailand. As long as you can collect food waste, you can easily digest food waste into in one of these fermentation, and at the end you can definitely produce either electricity or clean biomethane, as well as organics output, organics compost output, and of course you can save greenhouse gas emissions. So in this picture is the incinerated inside Chiang Mai University campus that is taken about 15 tons of organic waste per day. Those organic waste are collected from campuses, canteen, market, walking street, restaurant, inside campus and around campus. We work with municipality. So this is a proof that if you want it bad enough, you can collect these food waste separately from other waste. And when they come separately, they are very straightforward to take care of. So we have one facility. We are expanding this idea and technology to municipality all over the countries. And another technology I like to introduce is basically clean biomethane gas. This plant is use palm oil mill effluent biogas and convert into biomethane, which is cleaner than natural gas. And this gas is required by new industry that want to keep their carbon footprint low. So there are new market developed to accept this clean biomethane gas, either in compressed gas like this plant or in liquefied gas like this plant. So it's technology-wise, it's very possible. I'd like to introduce to you last few slides that we have set up initiative, so-called incentive platform for people to ways. So what you see in this map is the map of restaurant around Chiang Mai University campus area. So we have them registered in the platform. And then whenever this restaurant has food waste, they can register, they can call the collectors, and they can gain credit from the methane that we have produced that is equivalent to the methane that they have avoided from not mix these food waste with other waste and be emitted elsewhere. So we collect those methane and utilize and emit only carbon dioxide. So we, at the end of the year, give them some certificate of how much methane you have saved by delivering or preparing, collecting how much food waste to this facility. And at the end of the day or at the end of the year, these facility can enjoy, their contributions on how much greenhouse gas emission they have been avoided. And lastly, what I like to introduce to this panel is the compost from that facility is also implemented or applied to this so-called campus plantations. And if you notice, the roof of this plantation is also solar panels that is semi-transparent. So in the future, we believe that circular economy means you are independent in energy, also in food, also in nutrient, also in economies, meaning it's not just waste to energy, it's basically multiple circle combined together into a circular economy. So we have this demonstration going on in our campus, and this is what I'd like to share with you with the panels today. That would be my last slide. Key takeaway would be a ton of food waste is basically easily 100 cubic meter of biogas and easily 200 kilowatt hour of electricity. So since the time is short, I'd like to end my presentation today. Thank you all, the audience and colleagues. And I'll take the question after the second speaker. Thank you very much.
Okay, thank you so much, sir, for the presentation. It's very exciting. It was very interesting to learn how food waste can be transformed into a valuable renewable energy resource and like also contribute to sustainable energy development. Okay, such a pleasure to have you here, sir. Okay, so for the next experts, what is it? Let me share my screen. Okay, so for the second experts, we will have Dr. Nur Izri Abdul Wahab from University Putra Malaysia. and he will be discussing about AI-driven integrations and optimization of renewable energy problems. Okay, so Dr. Noor, are you already here with us?
I'm here. I'm ready.
Okay. Okay. So without any further ado, the time and screen is yours, sir.
So is my slide visible?
I
Everybody can see my slide, right?
yeah, I think yeah, we can
Mhm.
see it clearly.
Okay, thank you very much. Okay, Assalamualaikum and very good afternoon to everybody, to everyone. Thank you, Madam Mr. Chairman, for the introduction, and thank you for the previous presentation by the other brands. It's a quite interesting topic. So the topic that I will be discussing today is AI-driven integration and optimization of renewable energy in modern power systems. So these are my presentation outline. So we have motivation, challenges, AI in power systems, renewable energy, and AI integration, and some examples. Okay, so for the motivation of this uh, renewable energy and the integration of renewable energy and AI is because of the global transition. So it is shifting towards more to sustainable and clean energy systems. And now there is an increase of renewable energy penetration, okay, from solar, from wind, and from other renewable sources. And there is a need for the system to be intelligent. Okay, so these are the slide showing the renewable energy penetration in terms of in the world by continent. So you can see that the most penetration comes from in the South America. So it's like 60 to 70%. Okay, so in Asia it's about 20 to 30%. Okay, so the I mean in terms of penetration of is gaining the number is going up year by year. Okay. So, what are the challenges of this penetration of renewable energy? So, the challenges are the first is I think everybody should know the intermittency of this renewable sources. Okay, because you don't, for example, solar, you don't get it at the night, and also in the daytime, the radiation the radiation from the sun is not that uniform or stable. Okay, there's uncertainty in terms of the weather and the load also and the voltage instability because when you have that high penetration of renewables, it can affect the voltage, can provide or can cause voltage fluctuations, and also frequency fluctuation also will be there because when we have for renewables, so we don't have the moving, I mean, moving sources like previous generators, single generator. So that's why we are losing the inertia or in the power system. So it then any what happen it will affect in terms of the frequency and stability of the system. And then this is another the term that I think they have already about 5 or 10 years. Okay, power system flexibility. This term is to I think to integrate. I mean to provide like a bridge for because why this term comes up because of the need to the ability to adapt to the supply demand changes and handles renewable variability and also support stable grid operations. Okay, so you have because you have the conventional system, you just have like the generation. So now you have like smart grids and renewable energy connected DG also. So that uh, injection or the penetration of these sources may affect the uh, system stability. So the system need to be flexible in order for it to be able to supply system power or energy consistently lah. So the flexibility is bridging reliability and resilience. Before we have only power system reliability and also power system resilience. Okay, but reliability is what is actually reliability is for to operate at a secure operation. Okay, and also the resilience is to be able to withstand any disturbance, and then the system to come back to the normal position. Okay, normal operation. So the flexibility, constant step flexibility is actually the bridge between reliable and um, resilience of the power system. Okay. So this is the source of power system flexibility that I mentioned just now. So you have that distributed energy resources, flexible generation, okay, and then this also AI based control. All this requires the system to be flexible. So why AI? Why AI need to be introduced in operation of a power system? Because it handles non-linear system. Because the power system, the grid, the system is very non-linear, and it requires real-time decision making. Okay, and also the ability for predictive capability. Okay, so these are some of the techniques used in terms of the AI. Some I think we call it as machine learning. We have deep learning. Now about this about new technique, right? Deep learning optimization, optimization techniques. Okay, you before it was we call it as a genetic algorithm, but now already advanced. You have different techniques, and then you have the reinforcement learning. So before, you also have like artificial neural network, fuzzy logic, all this, which is also part of AI. Okay, so as I mentioned just now, these are the technique normally used in power system research, right? ANN, artificial neural network, physiology, genetic algorithm, okay, and particle swarm optimization. Okay, and so these are the architecture, the AI architecture for power systems. So initially you have the data sources, right? From maybe from SCADA, from the phasor measurement units, or from the things, okay, the sensors and everything. So this data will go in processing in terms of pre-processing to clean the data. Okay, that the important data included in to be past the AI model. So the AI model, for example, ANN, LSTM, okay, long short-term memory, and then machine learning in order for it to learn and also to get some according to the sort data to get the solution, and then the output is the decision, and then from that decision it will be used for system operation, for example for stability, voltage stability, or for optimization of power system. And this in terms of the integration, renewable energy integration flow. So you have the data from the wind or solar or wind generation, right? Or biomass. So that one it can be is already normally is variable, it's changing, and it's uncertain. Okay, it's forecasting model, the AI model for to forecast AI, I mean the sources, and you have for example the VLC on load for transformers and also inverter and then also for storage, control I mean the system, okay, from frequency stability or voltage stability, and when we have this control, then we have a stable grid operation. So AI for renewable integration. So for example, we have a solar forecasting, so you can forecast in terms of a number of years. For example, if you have a good amount of data, maybe 10 years, 5 years, 10 years, so that one can be used to project for the future. Okay, what is the solar forecasting for the future? So in terms of that, we have that number of solar panels that you want to use. Then the number of solar panel will increase in terms of the capacity from the solar panels to provide electricity. And then wind prediction also. Okay, I think in Malaysia the wind is not that good, so that's why not many research is done in terms of the wind, in the wind prediction or wind turbine. And then smart inverter control and also the OLTC coordination. Okay, this one is for the voltage stability or for to increase the voltage in the uh, transformers, right? And then AI for optimization. So optimization, so you can use optimization for economic dispatch, optimal power flow, and also energy storage, scheduling, or EV charging. Okay, so when we do optimization, we need certain constraint certain constraint to make instrument is operating at a very at a optimized level, right? Optimized level. This we use the AI because we can have a number of objective function, they call it objective function or the constraints, so that you can achieve the best solution. So previously, in terms of the calculation, we can only maybe one or two objective function only. So it's not that easy lah to get that to consider all the constraint. Okay, so this is why we have if we can integrate the optimization for AI using for optimization of the power system operation. So these are the examples that I have used AI in my research. So I have used AI in my research. For the first one is in uh, in stability, okay, specifically in power system transient stability. And second, in power flow, because in power flow, when you do the load flow studies, or normally we use the neutral interruption. So when you use interruption, so you have that Jacobian matrix, right? When the bigger the small system, the Jacobian matrix also will be big, and you need to inverse the Jacobian matrix. So sometimes you cannot get that. When you do the inverse, sometimes you cannot to get the output because it will be very, very difficult to do the calculation to do the inversion. So using the AI, maybe what we can do here is we can bypass that Jacobian matrix. So and then still give the good result, and also you can use for the ill condition system where the normal neutral transfer technique is not able to get the output. Okay, there's no convergence, it's diverged. So you cannot get the results. So, and then the third example is on reliability. Okay, reliability using this AI. And in terms of control, load frequency control, automatic load frequency control, virtual image here, and also optimization. Okay, technique have been used in my work. So this is just to show the sample example of the flow of for the virtual power plant, because now I think the research is moving towards this virtual power plant. Okay, so you have a number of inputs, and then you have the AI controller, and in this AI controller we have this the virtual power plant platform to do the calculation for grid, and also in terms of marketing. You want to sell the energy, buy and sell energy. So for the future, for AI, so we have this VPP, that previous slide showing the and then you have this new term also AI, where the
Mhm.
smart grid. Okay, we have number of smart grid. So you have that you can do the pricing and also the buy and selling of energy. Okay, using this platform lah, using AI. Okay. So as a conclusion, the AI improve the and also key enabler for smart grids. Smart grids. Okay, so both intelligent and adaptability and sustainable.
Okay, please wait, guys. I think Dr. Nur
Uh,
currently have a
attention
bad
to
connections.
the
Okay. Okay. Thank you so much, sir. Thank you for the excellent presentations. So your explanation on how can AI can support renewable energy integrations and also improve modern power system was really informative and inspiring. It's so exciting to me. And okay, let's now move on to our next agenda. Please wait a second. Okay, so for our next agenda is Q&A sessions. So I think I've seen several questions here. Uh, Let me help to read it. And to all of the participants, if you guys may have a questions, you can write down on the chat box, and don't forget to also mention the name of the speaker. And if you want to ask directly to the speaker, you are also allowed to do it. Okay, so for the first questions, okay, I think it's coming from Mr. Marvin Tejada. So the questions, I think this question is for Dr. Noor. Yeah. So how will the aims of renewable energy to emissions target be achieved if the resources to build it, like metals, minerals, are still being extracted with high embodied carbon? Okay, I think I would like to invite Dr. Noor to answer the questions.
Okay. I think
Okay, I'm sorry, sir. I think Carly, your connection is not really good. Uh, or maybe you need
I
uh more time to maybe like exchange the.
that's strong. Yeah. So the RE, right? The RE, that little bit compared to the previous conventional system, you have the diesel generators and all this. Compared to like a solar panel for the RE. So I mean, in terms of the carbon emission is less than the previous one, the solar panel or the and even the wind turbine also. Maybe wind turbine maybe it's not always built by metal or what, you know. So and then the source is also renewable. So in terms of the carbon emission, maybe it can be reduced in terms of that lah. Okay, and also in terms of the
没有这个新产
in terms
成
of
啊，
other also.
很疯。
Okay, so that is what I can answer. So if you want to look in terms of detail, maybe it's not that easy to see, but you have to look at the system as a whole. You know, if you want to, we have to compare the what we have now, the RE and the previous. You know, if you look just the RE, maybe there is still carbon, but if you look compared to the previous technology, maybe this technology is better in terms of that decarbonization lah. Yeah, so that is my answer. Thank
Okay,
you.
thank you so much, Mr. Noor, for your great answer. Okay, I hope it's answering your questions, Mr. Marvin. Okay, let's move on to the next questions. So the next question is coming from Denona. So good day, I'm Denona, a student researcher from the Philippines. I am currently working on a biogas technology inclined project. An insightful questions I would like to ask to Dr. Pruk Anggarasi, which breakthrough in biogas technology. So, do you believe biogas technology could create the most significant global impact in the next decade, particularly for developing countries like the Philippines? Okay, I think I would like to invite Dr. Brook to answer the questions first.
Yes, thank you for the questions. I wouldn't call biogas a breakthrough at all. It has been forgotten. Basically, it's been there for a century. We have been too convenient in our habits. I think that's a bigger problem, bigger topics to be discussed. Biogas system is very developed, especially as I mentioned that in Thailand 30 years ago, people are against it. They don't want to put extra effort, but now things can change. Things have changed. and it become common practice. And I believe the reason is from many aspects. Sometimes from social pressure, when you have industry or farms without proper treatment, you get social pressure. Financial pressure, for example, the energy prices keep increasing for the past 3 decades. That's a pressure. And also globally, people start to pressure you for a lower and lower carbon footprint, and methane happens to be one of these causes. So I think everything in between, but at the end of the day, I think education would bring everybody to the same page. Everybody would need to want to do it, and then keep it sustained, keep it a part of the life. I think that's how you proceed with the idea. And the technology wise, it's very available. Even the Philippines, I have been with a few companies to implement some biogas project there. So everybody everybody has to work together on this sense.
Okay, thank you so much, Dr. Brook, for the great answer. Okay, to Miss Denona, I hope it's answering your questions. Okay, next, I would like to invite Dr. Nur to answer the question. So, the questions also coming from Denona. So, what balance should exist between human decision making and AI automation in modern power systems?
Okay. In terms of this balance, so normally I think for me, I think is for example maybe in terms of the balance, I think your human should be 70%, 70 to 30% or 80 to 20%, because the AI that we are doing is not like it's a controlled AI. They call it as a narrow AI, which is used for the specific purpose. Okay, not like in other field we have a robot, a human robot or something. So that one maybe they have maybe a certain it's not a control, maybe a control, but maybe they have a lot more application, right? Or a lot more they can do a lot more things. But here for power system, because this the system is it need to be have a secure and and safe. So in terms of the AI, I think maybe 20 to 30% can be used, and we have to use the narrow AI, yeah, where we can control the output, and if anything happen, we can just put the emergency button and switch off all the AI, before it's going back, okay, or going haywire. So that's why I think that is I think my answer. Okay, thank
Okay.
you.
Yeah, so don't let AI control 100% is 70% for human and also specific purposes and tasks for AI. Okay, great answer, Dr. Nur. Thank you so much. And I hope it's answering your questions, Denona. And okay, so for the next questions coming from Hafiz. Uh, okay, wait a second. Yeah. So yeah, I think I would like to invite Dr. Nur Izzi again to answer the question. So
Mm.
the question is how machine learning algorithms are optimized to calculate bidirectional energy considering battery energy storage systems and community energy storage systems for on-load task changer application.
So this is
Oh.
very very specific. Maybe not enough in terms of to answer in 1 or 2 minutes. Okay, so I think this one we have to have like I think it's not that easy to answer this one. Sorry, for all load tap changer, actually this one is normally what I understand is no all load tap changer is actually at the transformer part, transformer side, like in maybe in the primary or secondary of the transformer winding. So it's actually to improve the voltage or to reduce the voltage, because sometimes because of you have that um, maybe the transmission line is long, or you have that voltage at the end of the line before going to the transformer. Maybe the voltage there will be drop voltage because of the load and everything lah. Okay, so you need to have that check changer to improve the voltage, maybe 5%, to improve the voltage level. Okay, so for that battery energy storage, because we don't have now. If we have like a smart grid, then you have that transformer, and then you don't have that moving generators. Okay, so when you don't have that moving generator, you don't have that virtual inertia, the inertia to actually to support the power system. Okay, previously because we have very big generation, so that's why the grid is very stable. But now because you get the solar, solar, for example, solar panel, wind turbine, so but they are you have very low inertial constant. When you have a low inertial constant, anything happen, you have to have it will be collapsed, the system will be blackout or whatever, lah, right? So when you have this battery energy storage, so it can be used to support as a virtual inertia, using the output the virtual inertia in terms of the controller. Okay, the output of this battery energy storage to support to provide the virtual inertia to the power system, so the power system will be much more stable. So I think now even I think you see in Asia, so some of the I've seen from my student, my ex-student, they mentioned to me that now when they want to build like a solar panel system, so they have or the other RE system, they have to have this battery energy storage for to provide support of this system lah. Okay, to provide support of the system. So that is what I can answer from this question. If you want to know more, maybe you can come to my university and do research with me. Okay, thank you.
Okay, that will be so exciting. Okay, thank you so much, Dr. Noor, for a good answer. Mr. Hafiz, I hope it's answering your questions. Okay, let's move on to the next questions. Okay, I think now I would like to invite Dr. Prup to answer the questions. So the question is from Nisa. Hello, Dr. Prup. My name is Nisa from Indonesia. So food waste is often overlooked as a renewable energy source. So in your opinion, what strategies are needed to increase public awareness and stakeholder engagement regarding these potential resources and why?
Okay, and I think I can wrap together two questions. I have seen another questions as well. Food waste shouldn't be there at the first place. I think Marvin, you're right about that. You should not waste food as a priority. But if it does, there are a few things that you can do before sending it to renewable energy or worse, landfills. So you have to at all costs avoid to have food waste. Or if you do have food waste, unavoidable food waste, then you have to do something with it. For example, you make animal feed with it. You can make improvement with it. You can do lots of worm farms to get valuable protein from it. And then at the end of the food chain, you put all the food waste left over to produce energy. But then again, I think I have mentioned that we have been too convenient regarding food waste, and it's been practiced in Thailand as well, especially that you eat have food waste, you wrap it up in the same package that you have bought the food in, like plastic bag or plastic box, and you throw away the bag or whole box, and you consider that clean. That was okay 40 years ago. Now it creates a multiple complex problem to waste management. So we have to stop doing that. So I think the priority is to educate, especially newer generation, that mixed food waste wrapped up in container is not very sustainable. Then we would hope to start seeing change. So I don't know what other public awareness can be done, but more and more you get pressure from environmental aspect, energy aspect, financial aspect. So I times come, at least say technology is available. It's only the human. If human are ready, then I think we can easily switch to a sustainable pathway.
Okay, yeah. So yeah, the first priority is to educate the new generations also, yes, sir. Okay, thank you so much, Dr. Brook, for your great answer. I hope it's answering your questions, Nisa. Okay, let's move on to the next questions. I think next questions from Rifda. So now I would like to. Okay, wait a second. Okay, I think yeah. So from Rifda, the question is for Dr. Pruk again. So, okay, I think maybe just one questions from Rifda. Looking ahead, what future opportunities do you see for integrating food waste-based energy systems with smart cities or sustainable community development?
Right. If you look into the future, it's very interesting because now if you care about circular economy and sustainable living, so food waste can play a good part, and especially when it's integrated with a smart grid of Dr. Noor. Um, Basically, methane power plant, even at community base, is naturally energy storage, meaning you can store methane and convert that into electricity or heat at any time you want. So it's really a good integration to a so-called small grid or microgrid at lower level, and it's will definitely integrate it into higher renewable energy ratio grids or even close to 100% because when you have enough energy storage. So looking into the future, I would say, okay, energy wise, you should and you must be relying more on these renewable resource. Food wise and nutrient wise, I think biogas should already be in the community. You shall not or you should not export or waste nutrient outside your community and keep buying new nutrient and more chemical fertilizer and put them into the cycle, because that wouldn't be not sustainable at all. So we should start thinking about everything all together at the same on the same aspect. I think that question is very good. We should look forward to that.
Okay, thank you so much, Dr. Crook, for your good answer. Okay, so Rifda, I hope it's answering your questions. Okay, maybe for the last questions, wait a second. Okay, I think next question from Johanna. So I would like to invite Dr. Noor to answer these questions. To Dr. Noor, so in your opinion, how can AI help address major renewable energy challenge such as intermittency and uncertainty in modern power systems?
Okay, so for this one, we have like solar panel, solar panel, and also wind, and also some other renewable energy. So I will talk only on, I will discuss on just solar panel, because when you have a solar panel, so you want to send to the grid, right? Or to send to the source or to the grid. So you have to send AC, right? But you get the source uh, from the sun is DC, right? DC, so you have to convert. So you have to convert DC to AC. So it's called inverters, lah. So that inverters, so that I mean the output from the inverters, the capacity from to get that output will change according to the day. Okay. To the time of the day lah. So maybe in the morning, maybe it's small, and then towards the afternoon at 12 p.m. or 12 in the afternoon, that is energy that you can, right? But there is a technology that to get to improve this intermittent is you may have to throw the thing of the solar panel, yeah, to get the most of the output from the solar panel. So that also can be used in terms of AI lah. In terms of this, I mean, to convert from DC to AC also, you can use AI for the power electronics controllers, right? To get the output. I mean, to optimize the output of the solar panel. So this is where you can use lah. So that is the how you want to. Maybe you cannot get, but you can get at certain time the best or the most you can get from the solar panel. Okay, and maybe you have
Okay.
to have like maybe this like a voltage regulator at least to from that solar panel, right? So that is what can answer. Thank you.
Okay, thank you so much, Dr. Noor, for a good answer. To Johanna, Miss Johanna, I hope it's answering your questions. Okay, guys, so since we're running out of time, I think we're going to end the Q&A session for now. So it's been an inspiring session. So thank you so much to Dr. Noor Izri and also Dr. Brook for your time. Okay, now let's move on to our second sessions. Okay, so on these sessions, we will have another two experts, which is from Dr. Jundika Chandra Kurnia from Curtin University, Malaysia, and then the next experts from Dr. Lucy Safriani from Universitas Padjadjaran, Indonesia. Okay, so for the first expert for these sessions, we will have Dr. Jundika Chandra Kurnia. He is from Curtin University, Malaysia, and he will be discussing about hydrogen vehicles in the renewable energy transition with barriers and integration pathways. Okay, to Dr. Jundika, are you already here with us?
Yep.
Okay, sir, without any further ado, the time and screen is yours.
All right, thank you very much. Good afternoon, everyone. Okay, hopefully you can see my screen. All right. It's a hard time after presentation by Dr. Brook and Dr. Noor, which is very inspiring. Right, so I will just quickly go through about the integration of hydrogen vehicle in the renewable energy transition. What is the challenge and what is the way forward? All right. Okay, let me see why I cannot move it. Sorry about that. All right. Okay, so let's take a look at the current energy landscape. Our economy has been relying heavily on fossil fuel, as Dr. Nora and Dr. Brook mentioned, and you know that this benefit to our life, our economy, but it also has some how to say bad side. All right, the bad side is of course first the fluctuating on the price, especially when there is a disruption like the current war in the Middle East. Right, the price is shooting up, so it's really trigger anxiety to global economy. And as we know, the usage of consumption, the fossil fuel has this major effect in our daily life. Right, in many countries, especially in Southeast Asia, actually air pollution is mainly driven by the use of fossil fuel. Right, I mean, yeah, we are the culprit. We cannot blame anyone else. We are part of those problems, right? Because we love to drive a car, we love to use electricity, and so on. So as we can see here, that the air pollution is getting worse day by day, and we need to take an initiative to stop it. So what shall we do as a community, right? Should we just let it happen and then the society will suffer in the future, that it's getting hotter and hotter? I'm not sure in Indonesia or in West Malaysia or in Thailand, but in East Malaysia, we have been experiencing like a very long hot season recently. It was so hot. Thanks God. This week we have our first rain, so it feels so good now. Right, but we need to do something, right? So one of the initiative that we can do is to have the so-called transportation transformation. Okay, so basically transportation transformation is an initiative to shift from the heavy use of internal combustion engine, which mainly use fossil fuel, into the more green, we call it, right? Battery electric vehicle or hydrogen fuel vehicle, right? So to bridge those, actually we have embarked on it. We have a lot of hybrid vehicle already available. And even now, I believe most of us know what is electric vehicle. Most of us know Tesla, most of us know BYD or Muda whatsoever. We have been very familiarized with that. Okay, so what is the difference between battery electric vehicle and hydrogen fuel vehicle if we are looking into that, right? Both are deemed as or refer as a future vehicle. Okay, so battery electric vehicle, fortunately, it has a bigger market as compared to hydrogen vehicle. So if we are looking into the market, I think the battery electric vehicle is many times bigger than the hydrogen vehicle. Battery electric vehicle is basically much simpler because it has fewer moving parts, so that the maintenance is very low. In fact, my friend told me that her EV car is only need like few, not even 200 ringgit per year. So it's very cheap as compared to my internal combustion engine vehicle, which need service every 6 months, and it can cost me like 500 to 1,000 depending upon, right? And then battery vehicle also have a rapid expansion of charging infrastructure. I believe in Indonesia you get a lot of charging, and in Malaysia also there is a growing number of EV charging everywhere. And the battery cost has been declining. That's why now you can get a very good electric vehicle car at cheaper price, especially with a strong policy support where we have incentive and so on. Something that is not really experienced by hydrogen vehicle. Hydrogen vehicle is more complex, right? That's why you rarely see Toyota Mirai on the road or other hydrogen vehicle. Okay, in Sarawak, currently we are embracing that. We will have ART, autonomous rapid trail, which will be hydrogen powered. And also there is a bus, hydrogen bus in Kuching. Unfortunately, has been decommissioned recently due to the cost, but it has been there before, right? The good thing about hydrogen vehicle as compared to battery electric vehicle is it is fast to recharge, to refuel rather than to recharge, right? Even if the battery has a supercharger compared to the hydrogen refueling, it will be still slower as compared to those. Now, if we are looking into hydrogen vehicle, we have two type of hydrogen vehicle. One is a hydrogen fuel cell vehicle, which basically just an electric vehicle with fuel cell as the electricity generator. Whereas the more mature is the so-called hydrogen internal combustion engine vehicle. Basically, we are using our normal car, but instead of using gasoline or diesel, we replace it with hydrogen. However, for diesel engine, the use of hydrogen is not so common because the cetane number of the hydrogen is not that suitable for our diesel engine. That's why it is mostly for the gasoline or petrol engine, right? If you compare both, actually hydrogen ICE vehicle has a higher maximum power output, so it is more suitable for heavy vehicle like truck, train, and so on, right? And it is cheaper in terms of per kilowatt. However, it has a lot of moving part in the engine, and it is not truly a green vehicle because there is a combustion, right? Although you combust only hydrogen and oxygen, but at high temperature, the nitrogen will react with the oxygen and it will produce NOx, right? Nitric oxide. So that one is not so clean in that sense. Okay, so this is some sample of hydrogen vehicle. I believe some of you have seen it. Maybe not on the road, but you can clearly look at it at the internet. All right, the most commonly used one is Toyota Mirai, right? And the second one now is Hyundai Nexo. In Sarawak, we have the Sarawak ART, which is produced by CRRC, China Railway Corporation. We expect to have it by next year, right? And there are several other company that has create hydrogen fuel cell vehicle like Suzuki, Airbus, and Boeing actually both are working on developing engine for the aircraft. So in the future, maybe we have a aircraft fuel with hydrogen, not with kerosene-based fuel. All right. Maybe hydrogen fuel cell vehicle, most of us know it. You have heard about it, but the highs, uh, maybe most of us not really knew. Oh, there is. Yeah, it is actually there. In fact, there are several company that is familiar with us, like Toyota. Toyota has a Corolla Cross H2, and they see those as the future of the transportation, right? That's why Toyota is not really into electric vehicle. They are looking into this hydrogen internal combustion engine. Kawasaki with their HICE project is also working on that, and also Cummins, and Cummins is mostly on the heavy vehicle side, right? And also Yamaha is developing 5-liter V8 hydrogen engine. Now, if we are looking into this, it seems like, okay, why then hydrogen is not really blooming as a battery vehicle, right? The problem is, if we are looking into it, we have a lot of problem, right? But if we go deeper, the problem is this one, hydrogen production. Hydrogen production is very, very costly. At the moment, hydrogen is not really an energy source, but it is more as an energy carrier. So you store electricity, all right? You store electricity instead of using battery, like what Dr. Nur Izri said. We convert it into chemical energy in terms of hydrogen, right? So you are using electrolysis to produce that. So that you can use it. Transportation is easier than, right? I mean, like charging is easier. You can refuel the car faster and so on. But the problem is the cost and the efficiency of conversion from electricity into hydrogen. Unless we find a naturally occur hydrogen reservoir, which actually there are several consortium that is working on finding hydrogen mine. So they want to find the hydrogen reservoir, and then they try to tap it, and then we will have the so-called natural hydrogen, which is naturally occur. However, there is a challenge because hydrogen is so light. Once you drill it, it may just escape without you being able to capture it. So that is the challenge at this point of time. And you can see that the price of producing hydrogen is, if you can see here, is quite expensive. Producing gray hydrogen is very cheap from steam reformer, but then we coming back to the square one, which is we produce a lot of CO2 if we are producing it from gray. So we need to introduce CCS or CCUS. But when you introduce CCS or CCUS, of course, the price of hydrogen will increase. Or you are using electrolyzer to produce the hydrogen, not using the common grid, right? The fossil fuel grid, but you need to use a green grid, right? The electricity that is produced by renewable energy, right? So with that, then the price is increasing a lot. You can see that the price increased from 2.13 into 6.4, like 3 times more expensive than the traditional one. Right. And also the problem is hydrogen infrastructure. Now you can see this one. You can get it from station map. It's freely available. In Malaysia, only one hydrogen charging is available in Sarawak, in Kuching. Compared to this one, see, got a lot of EV charger available. In Miri recently, we've found like 1, 2, 3, 4, 4 supercharger available, right, as compared to this hydrogen. So we cannot really expect that someone like me will drive a Toyota Mirai without the charging station or without the refueling station. So it will be a bit of headache to have it. right? So the biggest problem is on the hydrogen availability and its cost. That is the biggest problem. And then another problem is on the technological challenge. Of course, platinum catalyst for HFCV is very expensive, right? Platinum, I bought one for my wedding ring. That one costs a lot. So we can imagine if we mass produce the hydrogen car and we still need to use platinum as a catalyst, then it will cost tremendous. There will be competition between jewelry and hydrogen vehicle. And also about the hydrogen storage, we are still working on it, whether we want to use compressed gas or liquefied storage or using a solid storage. That one we haven't really decided on where to go. Compressed gas maybe is more affordable as compared to liquefied, but compressed gas is quite dangerous also because you need to compress it at 350 bar for that or 70 bar minimum, right? But if we can use a metal hydrate, then the pressure will be much lower than that, maybe about 10 bar, 20 bar. So we are still working on that. And also about the carbon corrosion inside the fuel cell. So that is some technological challenge that we need to overcome. So what is the integration pathway? What is the moving forward? First, we may want to look into the development of hybrid systems. So we will utilize both battery and hydrogen, just like our battery and ICE engine, right? We have internal combustion engine with fuel plus battery. So maybe we can have a PHEV, but instead of having fossil fuel, we use hydrogen. But for that, of course, we need to have infra. So investment in infrastructure is very, very important. Especially, we need to foster regional collaboration. So the infrastructure development need to be for the whole region, right? For example, in Kalimantan or in Borneo area, we need to have it in Brunei, in Malaysia, in Indonesia, so that the mobility of that vehicle can be achieved. Right, and then we need supportive policy and regulation framework. Technology development is what we as an academician and researcher need to do, and then also investment in green hydrogen production. All right, I think that's all. Sorry for taking a bit longer time, Miss Chacha. Getting back to you.
Okay, thank you so much, Dr. Jundika. And I think I would like to answer the Dr. Jundika questions. I think it's been very, very hot too in Indonesia currently. So I agree with you, sir. Yeah, okay. So, but hopefully everything that we face today will be solved in the future. Okay, thank you for sharing such a valuable insight, sir. Okay, next, let's move on to our next speaker. Oh, wait a second. Okay, so for the next experts, we will have Dr. Lucy Safiani from Universitas Pajajaran, Indonesia. She will be discussing about innovative energy materials, unlocking solar efficiency, and energy storage. Okay, so are you already here with us, Dr. Lucy?
Yes, sure, Chacha. Can you hear my
Okay,
voice?
yes, clearly. Okay, without any further ado, the time and screen is yours. Okay,
Okay.
semangat Ibu.
Okay, thank you. First of all, good afternoon, everyone. And thank you for the committee for inviting me to this international expert sharing meeting. So today I will presentate about my talk about the innovation energy materials unlocking solar efficiency. So in this presentation, I will briefly discuss about the evolution of the solar cell technology, the role of advanced materials in improving solar cell performance, and some research example related to the dye-sensitized solar cell, reducing graphene oxide, and also whole transport material. So we knew that the solar panel is one of the energy that is abundantly in this world and environmentally friendly and can produce electricity without pollution during the operation. But and another advantages of the solar power is that the solar panel generally require relatively low maintenance and can operate for the long lifetime. But however, to make the solar power more competitive and widely used in application, we still need to improve, especially in the efficiency. Yeah, I mean that the power conversion efficiency and how to reduce the cost and also develop material that can be stable during the operation and scalable and environmentally acceptance. And here in this slide, yeah, this is the compilation of the best research cell efficiency from the National Renewable Energy Laboratory. So we can see here that uh, the photovoltaic technology has already been progressed significantly over the past few decades, and the improvement doesn't come only from the engineering design, yeah, device, but also from the development of the new material. At first, we can see that the crystalline the crystalline silicon solar cell is still remain dominant, but many technology also grown up, such as the thin film solar cell and the dye sensitized solar cell, organic solar cell, or here we have the perovskite, including the dye sensitized solar cell, also has been growing very rapidly. And the main message from this slide is that we need the innovation in material, which is one of the key to drive the improving in efficiency or reducing the losses, and also the most important that the solar cell can be used widely in application. And we knew that the photovoltaic effect was first observed in 1839. And since then, the technology of the solar cell has developed from basic scientific phenomena to the application today. And we can see also that the solar cell not only used in a conventional rooftop system or maybe in the solar farm, but they also being developed into the integrated photovoltaic, yeah, for the transportation, for the portable devices, and even maybe for the green hydrogen production, as explained by the previous speaker. And this is the evolution of the photovoltaic, yeah, from the first generation. Yeah, the first generation is mainly based on the silicon, yeah, the single crystal silicon usually used in this first generation. Even though the technology has already been mature, reliable, and also commercially dominant, but still the cost is quite high. And the second generation consists the thin film solar cell by using the amorphous silicon, or using the cadmium telluride, and also the copper, indium, gallium selenide. Yeah, and these materials has the advantages. For example, require less absorber material and can be fabricated on the large scale, on the large area of the substrate. And the third generation, researchers usually call as the emerging technology, including in the perovskite and also the sensitized solar cell, and organic solar cell, yeah, and also quantum dot solar cell. And the last one, or the fourth generation, this is the combining between the hybrid material, yeah, with the nanomaterial, material-based graphene, and also other functional material, yeah, especially to enhance the light absorption, the charge transport, yeah, reducing the recombination that is commonly used in the solar cell, and also related to the stability of the solar cell. And this slide actually summarized the solar family tree, yeah, and each generation has its own kind of material. They has also advantages, yeah, and efficiency range, and also potential application. So the silicon solar cell has already been very well known with the high efficiency and also maximum reliability, while the thin film solar cell offer the lightweight, yeah, and flexible structure. And emerging technology producing the solar cell, such as perovskite-based solar cell and dye-sensitized solar cell, offer low cost fabrication, and also not so high technique in made this kind of solar cell, and also can produce the printable device based on the solar cell. And the fourth generation focus on the hybrid material and using the nanostructure material, yeah, with the goal to achieve the higher conductivity of the material to be used as the active material in the solar cell, better stability, and also improving in performance of the solar cell. And some of the current material that is used in each of the generation, as I mentioned before, yeah, we use the many researchers use the single crystal silicon, and this is also in market. They usually use the single crystal silicon, and also the amorphous silicon, yeah, and the cadmium telluride to make the thin film, yeah. The cadmium telluride used because they need only low production cost. And perovskite and also the sensitized solar cell is the technology that is used recently, even though maybe it's not still in the market, but it shows the improve, yeah, rapidly improving in efficiency. But I think I would skip this one. So the challenge, although the solar power has many advantages, as I mentioned before, but still there are several challenges. Yeah, the first challenges is the efficiency loss. Yeah, so this is an we call it the optical loss. And the most challenges is there always occur the charge recombination, and also related to the instability of the material. So the second challenge is related to the cost, high cost in this high cost to produce the solar cell, especially by using the advanced material and in the fabrication process. And the third is the market integration, yeah, including the infrastructure, policy, and also energy storage issue. So this is the challenge we should find out solving, yeah, to solve this problem. And therefore, the roadmap for the solar technology must include the continuous research and development, yeah, not only in producing the advanced material that could improve the performance of the solar cell, but also in the policy support to accelerate the implementation of the solar cell in many applications. So here that I would also introduce to you all about what we have done in our laboratory. So I would like to explain about the dye-sensitized solar cell. So as I mentioned before, this is the third generation of the photovoltaic to convert the light, yeah, visible light into the electrical energy. So some of the advantages of the dye-sensitized solar cell is it has good price, yeah, to performance ratio, and relatively low fabrication cost, yeah, and it can work under low light condition, yeah, and wider illumination of the angle, because the illumination angle is very important to produce the high efficiency of the solar cell. So we modify, yeah, the solar cell, so the dye-sensitized solar cell. So the TiO2 photoanode, the TiO2, yeah, as the semiconductor oxide is used as the common material for the photoanode of the dye-sensitized solar cell. So we put the reduced graphene oxide layer into the TiO2 photoanode to increase the electrical property and also the optical property of the photoanode after we put the reduced graphene oxide layer. And this is the route for the fabrication of the dye-sensitized solar cell, yeah. First we have the TiO2 material deposited on the glass substrate of the ITO, and then we deposited also the reduced graphene oxide on the glass substrate of the FTO TiO2 by using the UV oven spraying method. After that, we put the TiO2 mesoporous on top of the reduced graphene oxide, yeah, and then we immerse, yeah, the TiO2 layer and also reduced graphene oxide layer into the dye solution, and then after that stacking with the counter electrode by using the surilin as the spacer, and then injecting the mosalite as the electrolytes. So this is the structure of the device of the dye-sensitized solar cell based on the TiO2 photoanode with the addition of the reduced graphene oxide layer. So we can see here that this is the UV spectrum, yeah. So we by adding up to 12 layer of the reduced graphene oxide, we can see that the absorption is increased. So increasing in the absorption will also play an important role, yeah, in improving the efficiency of the devices. So we prove by using the Raman spectra, yeah, to find out whether the reduced graphene oxide has already been deposited successfully or not in the top of the TiO2 photoanode. So here the Raman spectra show that there are D bands and also G bands, which is this is the ban for the reduced graphene oxide. And this is the photocurrent density voltage, and from this photocurrent density voltage we can find out, yeah, the efficiency. So the efficiency is quite increase, yeah, after we put the 9 layer of the of the reduced graphene oxide. So by using the reduced graphene oxide, which is this material has a very good electrical property, then we can see that the efficiency of the dye-sensitized solar cell also increase. And another improvement, yeah, another modification is by using the whole transport of the materials. Yeah, we use the spiral compound. So the basic concept of the spiral compound is connecting two more or less extended pi system with identical or different function. Yeah, through a common sp3 hybridized atom. So the advantages is that the perpendicular arrangement of the two molecular lead to the rigid structure, suppressing molecular interaction between the pi system. And as the and the spiral compound can have a higher solubility, yeah, and because this is the amorphous state of the material, it can handle the recrystallization. And the optical property, yeah, or the energy, yeah, energy system, energy band, yeah, for the spirometers is very good, yeah, with the TiO2 and also aurum if we use this is as the counter electrode of the devices. And we
Yeah.
use, yeah, the spiral method, yeah,
Sorry
because
to
this is
interrupt.
yeah.
I think you can wrap up for about 30 seconds.
Yeah, okay.
Yeah.
This is the last, yeah. Okay, and this is the device structure, and the route for the fabrication is almost the same with the previous one. And this is the characteristic, yeah. And we can see that after we put the spiral method for the 5%, the efficiency increase up to 10.84%. And I can conclude my talk in the summary, yeah, which is the solar cell is the evolution of the technology, and the efficiency by using the modified material has already been increased, and there are still some challenges, and of course the roadmap for overcoming this involve the piloting in research and development. Thank you for your kind attention.
Okay, thank you so much, Dr. Lucy, for the insightful presentations. I think it was fascinating to learn about the development of innovative energy materials and also their important role in advancing renewable energy technologies. Okay, now let's move on to the next sessions, which is the Q&A sessions. Wait a second. Okay, so I would like to remind to all participants, if you guys want to ask directly to the speaker, you are allowed to do it. And you can also type your questions on the chat box. Since I have seen some of the questions on the chat box, so I will help to read it. Okay, so I think for questions, again coming from Mr. Marvin. Okay, so I think Mr. Marvin is very exciting to follow the event, yeah. So okay, I think this questions is for Dr. Junika. So the questions is airplanes are a single most emitter and contributor to GHG. Do you think that hydrogen fuel can be an alternative fuel source other than fossil fuels? And there is a proposal to shift to electrification of airplanes, but they have issues on battery due to its weight. So what are the risks for hydrogen fuel vehicles? Can you please cite? I think I would like to invite Dr. Junika to answer.
All right, thank you very much, Mr. Marvin. Yeah, valid question. As I told you, hydrogen can be used for two technology. One is the internal combustion or even external combustion. And you know that the aircraft is using gas turbine, right? And there is a hydrogen fuel gas turbine. Yeah, you can looking into Airbus Zero E engine. That one is using fuel cell, all right, fuel cell to replace the battery. Why we are using fuel cell? Because basically, when you are having electric propulsion, what you need is just electricity, right? If you store it in a battery, the weight of the battery will be tremendous. But if you are using fuel cell, so what you need to store is just hydrogen. And hydrogen has a very high energy density per kilogram. So can it be used? Yes, it can be used. And then, if I'm not mistaken, there is a question about what happened with the explosion of hydrogen. Okay, this is a very valid question. But remember that hydrogen is very, very light. So when there is a puncture, when there is a leakage, hydrogen will rise before it start to accumulate. So the problem with the hydrogen is not in the open surrounding. If it is in the open surrounding, the chance of getting hydrogen explode is a bit slim. However, if you are having a leakage in a closed environment, in a confined space, hydrogen accumulation will be there. And then hydrogen has a very wide range of auto explosion from 4% to 75%. So it will explode easily. All right. So if it is used for aircraft, no issue. All right. Because when there is a leakage, it will just raise and then it will just go on to the atmosphere. But if you are parking your car in the underground car park, right, in Plaza Indonesia or in whatever hotel that has an underground car park, then there is a problem. That's why if you see, we have a recent publication just looking into hydrogen mitigation, hydrogen leakage mitigation in a confined car park. Yeah, I think that's Mr. Cha. Thank you.
Okay, thank you so much, Dr. Junika, for the good answer. I think it's answering your questions, Mr. Marvin. Okay, let's move on to the next questions. The next question will be from wait a second, from I think from Nisa. So okay, now I would like to invite Dr. Lucy to answer the questions. I would like to ask the questions for Dr. Lucy. So among emerging materials like perovskites, graphene, and nanotubes, which material do you believe is currently is the most promising for efficiency and systems?
Yeah. Okay, thank you for the question. So, actually, that the perovskite is one of the material that can improve, yeah, quite high the efficiency. But the problem is that perovskite use the lead. So, usually people will not use lead. So currently, the challenge is how to change, yeah, the lead by another material or another compound. So the organic perovskite is also now in research, yeah, and related to the graphene and nanotube. Yeah, graphene can be improve the efficiency as I mentioned in my slide before. But there is also some difficulty, especially in producing the 2D, I mean, two-dimensional graphene. It's quite challenging, yeah. And the nanotube, yeah, and the nanotube is the belong to the nanostructure, yeah, and it will be depend on the size of the nanotube to produce the good solar cell. Yeah, I mean that the efficiency could be depend on the size of the nanotube.
Okay,
Thank
okay.
you.
Thank you so much, Dr. Lucy, for the good answer. I hope it's answering your questions, Nisa. Okay, next, let's move on to the next questions. I think questions from ARA. So now I would like to invite Dr. Jundika to answer. So do you see hydrogen vehicles and battery electric vehicles as competitors, or do you believe they can complement each other in the future transportation systems?
Okay, as presented in the presentation itself, actually, if we are looking into it, right, hydrogen vehicle may be more suitable for heavy vehicle, where battery will become so big or tremendous for electric vehicle, right? So they should complement each other, not competing each other, because both are deemed as a green vehicle, right? So we should not compete them, but we should make them complement each other, right? So maybe for a small car, city car driving, we can use EV, all right? Or where there is available infrastructure for the charging, battery EV vehicle will be the best option. When there is long distance, you need a high power, then you can use hydrogen fuel cell or hydrogen internal combustion engine, so they can complement each other.
Okay, thank
Yeah.
you so much, Dr. Jundika. So it's better to complement each other, yeah, than compete, yeah, of course. Okay, I think okay, maybe for one last questions for Dr. Lucy. Okay, so the question is from Rowell to Quip. So, innovative solar materials like perovskites offer high efficiency but struggles with high humidity. How stable are these new materials for long-term use in high heat and humidity typical of Philippines and Indonesia?
We use of the in technology, we still have face some fact that this device still challenges in stability, yeah, stability, not only the material stability but also the environmental, which is the device is placed, yeah. So in the laboratory we fabricate, yeah, the device in the glove box so we can control the humidity, but of course we need this device, yeah, in application to be can be used in many kind of conditions. So this is one of the challenges research that most of the researchers have to face this one. So maybe the modification to find out the material, yeah, active material for the perovskite solar cell or other kind of solar cell. There is not only depend on the humidity is very important. Yeah, thank you.
Okay, thank you so much, Dr. Lucy, for the answer. I hope it's answering your questions, Mr. Rowell. Okay, guys. Okay, since we're running out of time, I think we're going to end the Q&A session for now. Yeah, it's been an inspiring session. So thank you so much, Dr. Jundika and also Dr. Lucy. And for the other participants that may want to ask another questions to Dr. Jundika, you guys can check Dr. Jundika's Gmail, yeah, on the chat box and send the questions. Okay, once again, thank you so much, Dr. Jundika and also Dr. Lucy. Now let's move on to the next sessions. Okay, so for the next session is group photo. So to all participants, please turn on your camera. And also don't forget to use our virtual background that can be downloaded on the chat box. Okay, I think I'm gonna wait for about I think 30 seconds is enough. And also I would like to apologize to all participants and also to all speakers that we in our sessions a bit late since we have such an inspiring sessions today. And also don't forget to follow our Instagram at pasita.education. I think my partner will send the details later on the chat box because we will keep updating about our events on our Instagram. Okay, maybe another 10 seconds. Okay, please kindly wait. Okay, maybe I will start counting down. Okay, maybe. Okay, can you guys smile? Wait, wait. Okay, 1, 2, 3. Okay, I think one more. 1, 2, 3. Okay, thank you so much, guys, once again. But please, wait a second. Wait, let me share my screen first. Okay, so I think we're coming to the end sessions of our event today. I would like to say thank you so much to all experts and also to all participants, and also to Dr. Jundika, Dr. Prook, and also Dr. Lucy and Dr. Noor. Thank you. It's such a pleasure to have you guys here in our events, and see you guys on our next events. And to all participants, don't forget to also fill your the attendance link, yeah, on the chat box. My partner will send the details later. Thank you so much, guys, and have a great day. Thank you so much, sir.
Okay, bye-bye.
Thank you so
Bye
much.
bye. Thank you so
Bye.
much. Bye.
To all participants, once you fill in the attendance link, please kindly check your email because please check your spam or your inbox because the e-certificate will be automatically sent to your email. Thank you.